Hello and welcome. Today, we're diving into a common challenge in software development: architecture erosion. What is it? Imagine you design a building with a solid blueprint. Over time, additions are made, walls are moved, and systems are patched, often without consulting the original plan. Eventually, the building becomes less stable, harder to navigate, and more expensive to maintain. Software architecture erosion is similar. It's the slow drift between how a software system was intended to be structured and how it's actually built as changes accumulate. This isn't a sudden collapse, but a gradual decay caused by new features, bug fixes, and adaptations. Often, quick fixes made under pressure compromise the original design principles. The consequences? Increased complexity, making the system harder to understand and modify. Maintainability drops, quality suffers, performance can degrade, and ultimately, development and maintenance costs soar. So what causes this erosion? It's often a mix of factors. Continuous changes, without strict architectural adherence, are a big one. Time pressure leads to shortcuts and technical debt. Sometimes, there's a lack of architectural oversight, or the architects and developers aren't fully aligned. Poor or outdated documentation doesn't help either, making it hard for developers to follow the plan. Requirements naturally evolve, but adaptations might be inconsistent. Developer knowledge gaps about the architecture or the impact of their choices also play a role. Even flaws in the initial design or integrating third-party technology, without careful thought, can contribute. How do we spot this erosion before it gets out of hand? Early detection is key. Regularly compare the code against the intended architecture. Code reviews are crucial for spotting violations and unwanted dependencies. Static analysis tools can automatically check for rule breaches and problematic structures. Architecture conformance tools specifically compare design models with the code. Visualizing the system's structure can also reveal degrading patterns. And sometimes, just recognizing symptoms like increased coupling or rigidity can be an early warning. Once you suspect erosion, you need to understand how bad it is. Pinpoint the exact violations in the code. Try to quantify the deviation. How far has it drifted? Assess the impact on things like maintainability, performance, and security. Investigate the root causes. Why did it happen? Then, prioritize which issues need fixing first based on their severity and impact. Finally, how do we fight back? Mitigation involves both prevention and correction. Treat architecture as something that needs continuous improvement, not just a one-time design task. Regularly refactor not just code, but the architecture itself to correct drift. Build resilience from the start with modular design. Implement strict code reviews focused on architectural adherence. Use automated checks in your build pipelines to catch violations early. Keep documentation clear, up-to-date, and accessible. Establish clear processes for architectural decisions. Manage technical debt proactively, treating architectural shortcuts as debt to be repaid. And strive for simplicity. Complexity is often the enemy. In short, software architecture erosion is a natural consequence of evolving systems. But it doesn't have to lead to decay. By actively detecting, analyzing, and mitigating it through continuous assessment, refactoring, and disciplined practices, we can keep our software robust, adaptable, and ready for the future. Thanks for listening.